Welcome back to solving multi-step equations. As a recall, what is an inverse operation? An inverse operation are opposite operations that undo each other. So remember, that is like addition and subtraction, and multiplication undoes division. Let's consider the following. Please excuse my dear Aunt Sally. So this is something that we've been stressing pretty much since day one, okay? We have our parentheses, our exponents, our multiplication, our division, addition, and subtraction. So let's get those down. Now, when solving equations that have two steps or several steps, doesn't matter how many, we always solve them by doing the inverse of PEMDAS to solve. So instead of us considering the parentheses first, we need to go back to the bottom and look at is there any subtraction happening first. So to solve multi-steps, we do the inverse of PEMDAS. It's kind of weird to get used to at first because we are so used to going in order of parentheses first. So it is going to take a little bit to get used to it, but if you always think of PEMDAS backwards, I find that helps my students the most. So let's look at these three examples together, solving two-step equations. Our first one is negative 3x plus 5 equals 2. So what I'm going to do to help myself remember is write down PEMDAS up here in the top. So remember, we are going backwards. So let's see. In this first example, do we have any subtraction? I don't see any. Do we have any addition? Hey, that positive 5. How do I move positive 5 to the other side? Well, you do its inverse. You subtract 5. So equations are really just going backwards a lot. And if you can remember that, it's not as scary as it sounds. So we didn't do anything with the negative 3x, so we bring it down. And this line here is just my way of dividing my work, so I'm not getting confused on what I'm actually looking at. And then we have 2 minus 5. Well, the signs are different. We subtract and keep the sign of the bigger number. So negative 3 times x equals negative 3. Well, we've done a lot of practice on these. We just do the opposite of multiplication and divide. So everything's coming back in from before. So negative 3 divided by negative 3 is positive 1. Again, just like we did in the past, if you wanted to, which I'm not going to require you to do this for a lot of them, but I know on your PSSA or other things, they may have you check to make sure it's a valid solution. So you would take your 1, plug it back in where you see the x, just like the x is right here. So we have negative 3 times 1 is negative 3 plus 5. Does that equal 2? Hey, it does. Would you look at that? That means that you did your work properly and you found the solution to that equation. Alright, let's look at part B. We have negative, we have x divided by 8 minus 1/2 equals negative 7 over 2. So we're doing PEMDAS backwards. Do we have any subtraction? Hey, that's a minus 1/2. Let's add and do the inverse of 1/2 to each side. And we're doing it to each side because equations are equal. They are balanced from left-hand side to right-hand side. We have x over 8, or x divided by 8 equals negative 7 plus 1 is negative 6 over 2. And I'm going to simplify this a little bit because we can. We have x divided by 8 equals negative 3. Now, this is just like a regular one-step equation. How do I get x divided by 8 to separate? Well, the opposite of division is multiplication. So I'm going to multiply each side by 8. So x is equal to negative 24. One last one to look at. We have m divided by 2 plus 6 equals 10. So very similar to the one that we did between A and B, just a little bit different. So we go backwards with our PEMDAS again. I highly, highly recommend writing this at the top of your paper when you're starting these out. It's just a good reminder. So we don't have any subtraction, but we do have this plus 6 here. So the opposite of plus 6 is minus 6 to each side. And make sure when you're lining these up that I'm going across the bridge or across the equal sign. Okay, that is crucial. Something that I do see a lot with kids, whether it's tutoring or at school. They don't want to go across the bridge. You have to remind yourself of that. 10 minus 6 is positive 4. And now we have m divided by 2 is equal to 4. We multiply each side by 2, just like we did in our previous video. And we get m equals 8. Alright, we are just about finished, but we have 3 more to look at. 2 of them are combining like terms before solving. So, intersection of like terms, remember, like terms are things that have the same variable piece, or they're both constant. So, if we look at A here, we have 3y minus 8y equals 25. 3y and negative 8y are like terms because they both contain just a single. So to combine these together, because they are the same variable, we have negative 3 minus 8 would be negative 5y equals 25. So this is a one-step equation now. How do we get the negative 5 and the y to separate? Well, they're being multiplied, so their opposite is division. So y equals 25 divided by negative 5 is negative 5. That's all you're going to do. Let's look at part B. We have 4 minus 2y plus 3 equals negative 9. Well, I know that the 4 and the 3 are like terms because they're like the constant number. So 4 plus 3 is 7 minus 2y equals negative 9. So to move the positive 7 to the other side, I need to subtract 7. Remember, our goal is to get the variable by itself, so that 7 needs to move first. So we get negative 2y equals negative 16. Just combine these two together. And then we have negative 2 times y equals negative 16. So the opposite of multiplication is division. Hopefully you guys are starting to see a pattern. They're really not as complicated if you just remember that it's the opposite. So negative 16 divided by negative 2 is positive 8. And there you have it. Alright, so our last example is asking us to describe and correct the error in finding the solution. So these are things that you'll see throughout our practice problems, our textbook, and even on the standardized testing. I always approach these by setting up my equation on the side here and work through it myself, because you'll notice they don't show like how they got from here to here, and to me that's very confusing. But if I take the time to work through it myself, I can definitely identify the problem a lot easier. Okay, so our problem is negative 3x plus 2 equals negative 7. So remember, we are just doing PEMDAS backwards. So do we have any subtraction? Nope. Do we have any addition? Yeah, that positive 2. So subtract 2 to each side, like so. And we're left with negative 3x equals negative 9. Is that what they got here? Yeah. So that step's not bad. So we have to continue on. So how do we get a negative 3 times an x to separate? Well, the running joke in my classroom was like, oh, they get a divorce. Well, they divide. So let's divide that by negative 3. So x equals negative 9 divided by negative 3 is 3. Is that what they got in here? Ooh, no, it isn't. They got a negative 3 as their answer. Well, let's see what happened. Did they divide by negative 3 here and here? No, they didn't. So our error in this example was they forgot to divide by the negative 3. They only divided by 3. So make sure you take that negative sign along the way. That is today's lesson. What you can work on now are the 4 examples in the on your own part of your packet. When you're finished with that, show myself, and then we can move on to our Go formative assessment.